B, C, and D. All right, so B is find the second derivative. So if we're given the first derivative is 2x minus y, to find the second derivative, let's see, rewrite this, dy dx equals 2x minus y. So finding the second derivative here, this is implicit differentiation. That's nice. So when I take the second derivative, remember this is our notation for second derivative, right? D squared y over dx squared. Derivative of 2x would just be 2. Derivative of y would be dy dx. Right? So now it says, write this just in terms of x and y. So I know that dy dx is equal to 2x minus y. So I can replace the dy dx here with 2x minus y.
Oh, I didn't get that.
So there's my second derivative, just in terms of x and y. Then the second part is determine the concavity of all solution curves for the given differential equation. And yeah, so we want to set this equal to 0 and figure out what's going on here. Right? So, let's see. So we'll have 2 minus 2x plus y. So we could, let's see. Yeah, I mean, we could take the 2 and the 2x over and say y equals 2x minus 2. Right, if we set that equal to 0. So what does that tell us then? Like once we set the second derivative equal to 0 here.
And this is in the second part.
Say that again? Oh, yeah. It tells us what's going on in the second quadrant. So, I guess maybe it doesn't. I missed the second quadrant part, I guess. So, if we're just thinking about this equation, in the second quadrant, what's true of x's and y's?
Isn't it 1, 2, 3, 4? X is on negative, y is on positive.
Alright, so if we're talking about quadrant 2, x is negative, y is positive. So what would happen here then? If I make all the x's negative, and the
Everything would
y's
be positive. It would be a
positive.
concave. Wait, concave up.
Right? If we're saying that all the x's are negative, the y's are positive, that would make this a positive and this a positive. So I would be adding positive numbers. So that means in the second quadrant, the second derivative will always be positive. Therefore, the original curve is always concave up in the second quadrant. Right? This one was kind of weird to think about. Does that make sense? I'll take that silence as a yes. I
I'm
guess.
writing. My pencil is being stupid.
Alright. Then part C, we want to solve our differential equation with the initial condition, f of 2 equals 3. So how can I... Oh, no, sorry, we don't need to solve it. We just need to find whether it has relative min, max, or neither. Log what and where?
Numbers in x's.
Yeah, if we're just trying to figure out min, max, or neither, I'm going to plug in 2 for x and 3 for y into the derivative. Right? The derivative is what's going to tell me information about whether we have a min, max, or neither. So if I plug 2, 3 in here, and I get, well, I guess let's just do it first, and then we can talk about what could have happened. So I plug 2, 3 in, get 2 times 2 minus 3 is 1. So if we get a slope of 1 at the point 2, 3, do I have a min, a max, or neither? Neither, right? Because what would we need here to have a min or a max?
It's 0.
0, right? The first derivative would have to equal 0. So since we didn't get 0, it is neither.
You also just said equals 0 and then find there's not.
Yeah, that would work too. Yeah.
Now D is just weird. I think it makes no sense.
This one is really, really weird. So what it's saying is y equals mx plus b is a solution to this differential equation. Right? So this line is a solution. So what we can think about is if I take this y equals mx plus b and I take the derivative of this, okay? So I take dy dx. Well, the derivative would just be m, right? So what we can say is, well, dy dx has to equal dy dx, right? So I can say 2x minus y equals m.
Or who?
Correct.
You would just put that back into that. No, just continue.
That's yeah. That would be one way that we could do it.
Go, Nicole.
So if we, well, no, because then we'd still have a couple of variables. So from here, it's were you saying to take this and plug it into here, or take this and plug it into here?
I was saying take that, but take what equals them and plug it into but then it doesn't matter. They have to do it.
Right. So if we take this mx plus b and plug it into here, then we can solve this and figure out what's going on. So 2x minus mx minus b equals m. So what we could do, get everything on one side, so I can subtract the m over. 2x minus mx minus m minus b. Minus b minus m, doesn't really matter what order you write it in. Then, I could factor in x out of both of these things. And then I could factor in -1 out of both of those.
Why is this a thing?
Yeah, I mean, this one was really, really strange. I mean, you can't predict the AP tests exactly from year to year, but I've never seen another question like this on an AP test.
I mean, if you don't get B, you have 6 points.
Right.
B is only worth 30.
B was also kind of weird. Yeah. Yeah, I mean, this whole question was strange.
Awkward.
Yeah.
Okay, continuing.
I flipped the page.
All right, so to finish this out, we need these things to equal 0, right? So what we can say is 2 minus m has to equal 0. So that would mean if I add my m over, m equals 2. And then we also need this to equal 0.
We have a equals 2, we can put 2, so b equals minus 2.
Exactly. So, and so that's the only way for these things combined to equal 0. Right? This one was a pretty strange problem. Okay, but does it make some sense? Alright. What else?
Can we do C on 2014 for some reason? I know how to do it, I'm just getting the wrong answer to something.
Sure.
If that makes sense. Like, I don't see how they got the y equals 3 minus 2.
Yeah, and I got a completely different answer for per.
Yeah, I have it
All right,
right.
so
I have E.
okay, just find the initial.
Because you should end up with e sine of x plus natural log of 2 plus 3. And the natural log of 2 and e like hands off. There's 2 left. That's what he wants out of 2.
That makes sense. Or should we go? Okay. So our original problem is dy dx equals 3 minus y times cosine of x. So we need to separate our variables. So I would divide 3 minus y over, multiply the dx. So dy over 3 minus y equals cosine of x dx. Take the antiderivative of both sides.
Negative.
So, yeah, so if we would really want to think about this as a mini u substitution, right? So we would say u is 3 minus y, so du is, negative dy, but we want it to be positive, so I would need to multiply by negative 1. So we get negative du equals y. So if I pull that negative out, we would just have negative du over u, so its antiderivative would be negative natural log of u, and our u is 3 minus y, so that's how we get negative natural log of 3 minus y.
It's equal to
35 seconds.
You always hit the recycling bin.
Maybe I'm just. Alright, so then what's the antiderivative of cosine? Sine.
Plus
Okay. Plus c. So now our initial condition was the point 0, 1. Right? So I'm going to plug 0 in for x, 1 in for y. So negative natural log of, since this is going to be a positive value, I don't need my absolute value bars anymore. Right, so negative natural log of 2 equals sine of 0 plus c. So we need to know what sine of 0 is.
Isn't it 0?
I said it was 1.
Which is it? Sine of 0, 0 or 1?
0 because the cosine of
We're talking about this point right here. And sine is the y value. So that would be 0. So we just end up with negative natural log of 2 equals c. So now we need to take that and plug that in here. So negative natural log of 3 minus y equals sine of x minus natural log of 2. Yeah, let's get rid of that negative sign first, though. I mean, it technically doesn't matter, but I'm gonna divide everything by -1 first. So negative sine of x plus natural log of 2. Then raise both sides to a power of e. So
Doesn't the natural log of 2 just not be there anymore?
what do you mean not be there?
It would just be
So yeah, we could rewrite this as e to the negative sine of x times e to the natural log of 2, and then e to the natural log of 2 is just 2. So we could write this as just 2 times e to the negative sine of x.
okay.
But we don't have to, right? We could just leave it like this. Then all we would need to do is subtract 3 and divide by -1. So we would end up with +3 minus e to the negative sine of x plus natural log of 2. And we don't have to simplify it anymore. I mean, we could do what we just said and say this would just be 2 times e to the negative sine of x, but we could also just leave it like that.
That was my problem. I just thought that the natural log of 2 raised to e would just be 2 plus 2, not multiply. That was my
Oh,
problem.
Gotcha.
So now,
Sweet.
then I subtracted, added the 3, so I get +1, and yeah.
Questions?
I think maybe if I don't see one 2015, I should be okay.
So on this one, part C was 6 points, right? Part A was 1 point, B was 2 points, and then C was 6 points. Yeah, for the 2014 one. And notice how important some of these things are. Like, if you forget your plus C, you automatically lose 3 points, right? So you can't do the rest of the problem if you forget your plus C. So, I mean, it even says max 3 out of 6 if you don't use plus C, and 0 out of 6 if you don't correctly separate your variables in the beginning. Okay, so those 2 things are very important. Okay, but I mean, it's essential to do the whole problem. And so, I mean, you need to separate the variables, and then you need your plus C to use your initial condition and solve. Okay. Any other questions on these?
No, it was on
So do we feel decent about these?
Yeah, I feel okay with it actually. I feel good when I have another problem sitting in front of me, and then I can just translate. Yeah, I can do the work of the actual problem. It's just a matter of understanding what is wanted without looking at another example.
Right, and that's the biggest challenge that you're going to see in the AP test, just figuring out what it wants you to do. So, I mean, you guys can do all of these things that we've talked about. It's just when to use what. So, no other questions on these? All right, today then we are going to start talking about area between 2 different curves. So everything we've done so far in terms of area has just been under a single curve, right, between a curve and the x-axis. So today we're going to look at how to find area between 2 curves.
Yes. I'm thinking. I saw that one. I'm hoping it's like that. But you know how he likes to kill us slowly. Oh, yeah. Perhaps.
Too bad.
Alright.
Oh, you took your Tupperware containers home.
I did.
Oh, we're mountain over there.
The mountain is no more.
Until then, it was me.
All right, so let's take a look at this first example. Okay, we're going to find the area between two curves here, but first we're going to find the area between each curve and the x-axis separately. So first, we're given f of x equals negative 1/2 times x minus 2 squared plus 6. So let's graph this function first. Right? And it's not super important that you're able to graph it by hand. Right? So I mean, we could use a calculator to get a picture of this, but what would this picture look like? I mean, you can grab a calculator and graph it on the calculator if you need to. Right? So you can then sketch this picture on your notes.
It's a big giant hoop.
So something like this, right? So we want to find the value of the integral from 0 to 5 of our function. So let's try this by hand. So how would I do this by hand? Yeah, so I'm just finding the antiderivative of this. Squared plus 6. One thing just to reiterate this. I finally finished grading your tests, your take-home tests. It took a while.
Yeah, you can put more grades.
Yeah, I put all the cons in here. But one thing that a lot of people forgot when they were writing out integrals was this, your dx or your dt. I think in some of the pre-responses we had on the test, it was dt. Okay, so this is really, really important to include when you're writing out an integral. I mean, I could get back today.
I want to see it so I can just
I
make
don't
my
want
hair.
to see it because I'm gonna fail life.
So how would I do this by hand? How would I take this antiderivative?
Well, you have to just pretend everything in parentheses is x. Right.
You mean this part? You can do that. Yeah. Alright, that's definitely one way we can do it. Just think about this as one term and this as another term. So what would the antiderivative of negative 1/2 times x minus 2 squared be?
Well, you add one. It's one of those pretty, so yeah. Plus 6.
Plus 6x.
Plus c. Wait, we don't need.
Right. Since this is a definite integral, we don't need plus c. So we could have done a u substitution here, but
if we're able to just figure out what that constant or the coefficient should be, we can also just do it that way. So now we would plug in 5 and 0. So negative 1/6 times 5 minus 2 cubed plus 6 times 5 minus negative 1/6 times 0 minus 2 cubed plus 6 times 0.
That's 27.
So negative 27/6. So might as well go ahead and write that with a common denominator, right? So 30 in terms of sixths would be 186ths.
Minus 8.
Yeah, so negative 8 times negative 1/6 would be positive 8/6. And then this would just be 0, right? So we've got negative 27 plus 180 minus 8. So that's minus 35. So 145/6. All right. Okay, so I mean, we could have used a calculator to do that, but good practice to do by hand. So what we just found, right, is all of this area, right, from 0 to 5. So now, the next part here says graph the function 4 minus 1/2 x. Okay, so that's just a straight line, right? What would that look like? We should be able to do this one without calculating.
Well,
It's going to have a slope of
negative 1.
negative 1.
And it's going to cross the 4. It's going to smack the 4 digits.
Right, so cross here at 4, slope of negative 1/2. So this line will do something like this. So now I want to find the area just underneath this line from 0 to 5. And so we could, there are actually a couple ways we could do this. Right? We could do this geometrically. We could just find the area of this trapezoid. Or we could set up a definite integral. Either way.
Calculator.
I would probably say doing it geometric.
Okay, so it's
So what is the area of a trapezoid?
1/2 times b plus 1/2 times height b1 plus
Yeah, so we could write it a couple of different ways. We could write it as 1/2 times the height times b1 plus b2, or like this. So oh, circle. Yeah. Circumference is 2 pi r. Pi times diameter. Less. So if I'm doing this geometrically, what are these pieces of information? What's the height?
5. Oh.
The height would be 5, right? The height would be the distance between the two bases. So the height
two bases would be
4 plus 1 and a half.
4, would be this one, and then this one.
1.5.
So to get it exactly, we know that our function is 4 minus 1 half x,
Oh,
right?
yeah.
So
Plug in.
just plug in 5. So 4 minus 1 half times 5 would be 3 halves, right? So this would be 8 halves minus 5 halves.
1 and a half.
So we're just finding our two bases, right? So this one's 4.
Yeah.
And then to get this one, we would plug 5 into our function to figure out what that height is, which is actually the base. So we would get 3 halves for that second base. Yes. So if we wanted to calculate this by hand, 5 times 8 halves plus 3 halves would be 11 halves over 2. Wait,
No.
multiply what by 2? So this would be 11 fourths, right? So we end up with 55 fourths. Are we okay with that?
So do we just subtract them?
Yeah, so what we found is that this total area here under the quadratic is 145/6. The area just under the line from 0 to 5 is 55 fourths. So then what we want to figure out is how to find this area, the area in between those two curves. So to do that, like Ruby just said, I'm going to take this total area under the quadratic minus this piece down here. That will get me just this area here. Right? So to find just this piece, I take the bigger area under the quadratic minus the smaller area, which is under the line. So 145/6 minus 55 fourths. I don't know, you put that in the calculator. What does that
Okay,
get
I'm
us?
about to say. Um, 125 divided by 12.
25 twelfths. So this area here, in between the two curves, is 125 twelfths. Could we have done this problem with the
No,
area?
like, what if we do like the top part? Like, how do you find the area? How would
So what we did, we just said that the area of this piece here is the area of that we found under the whole quadratic minus this piece. So we just said it was the whole thing, 145/6 minus 55 fourths to get this piece here. So when we're given problems like this, okay, so on the right side of the page, it shows us that instead of finding the two areas separately, we're just going to use our properties of integrals to combine these into a single problem, okay, a single integral. So we can just say that the area in between the two curves is the integral from 0 to 5 of the top function minus the bottom function. And I can do that as one problem, okay, instead of finding these separate. So if I wanted to do this algebraically in terms of one problem, right, what is my fx? Negative 1/2 times x minus 2 squared plus 6, then minus. So when we're subtracting, we need to make sure that we're using parentheses so that we would end up distributing that negative sign. Right, so I can just set up an integral like this. top curve minus the bottom curve, and that will get me the area in between. Alright, so from this point, okay, we could combine like terms and just create a single quadratic. It would end up being to anti-differentiate. Now, it's up to you how you would want to approach something like this. And we could square the x minus 2 here, then combine our like terms. That would be a little more algebra up front, then a little less work later. Or we could just take, combine the 6 minus 4 and then take the antiderivative of each piece there. Totally up to you how you would want to approach something like this if you were asked to do it by hand. Right. Are we okay with that setup? Okay, so the basic idea is to find the area between two curves. Just take the top curve minus the bottom curve. Right? So for time's sake, we're not going to go through this again because we know the answer. We know the answer is going to be 125 twelfths. Right? So real quick, let's take a look at this next example here. So on this next example, we are asked to find the area between these two curves. Now, we've got two different regions, right? We've got this region over here, and then I've got this region over here. I will have to set these, or split these up into two separate integrals. Why would I have to split this up into two separate integrals to solve? Because they cross, right? Because the top curve changes, right? Over on this side, the top curve is this function. Over here, the top curve is this function. Yeah. Yes. Okay. Now, the other thing that we don't know is where these curves intersect. Okay. So I need to know that to know where to put my bounds. Right. So part A says find the intersection of the two curves. How would I do that by hand?
Set them equal to each other.
Set them equal to each other. Right. So 14x plus x squared minus 2x cubed equals x squared minus 4x. So how would I do this? How would I solve this?
Well, the x squared
Yeah, the x squareds would cancel. Yeah, so then we could add the 4x over. I'm just so that our cube is positive, I'm going to take things to the right side. Alright, so I'll end up with positive 2x squared 2x cubed. And then if I subtract 14x over, minus 18x. I can take an x out. I could also take out 2. So I can say 2x times x squared minus 9.
Isn't that whatever?
Yeah, that
Difference of squares.
yeah.
So we end up with 3 answers. Right? We would get x equals 0, x equals 3, and x equals negative 3. So from the graph, I mean, we probably could have guessed that, okay? But we're not always going to have a graph. So I know that these curves intersect at negative 3, 0, and positive 3. So to set up my integrals then, okay, over here, which of these functions is greater? Is this the quadratic or the cubic that's on top? Quadratic. Right? So for my first integral, for this first piece that goes from negative 3 to 0, I'm going to say the quadratic, so x squared minus 4x minus the cubic, 14x plus x squared minus 2x cubed. Then for the second piece, the integral from 0 to 3 is going to be cubic minus the quadratic.
Can I stay in here to get my special and do this?
Sure.
I also just really don't.
I know my answer. Oh, I know my